up to Jeff Slostad from Tethers Unlimited. He's going to be talking about the persistent space platforms and bootstrapping and in-space economy. If there's a company that can do this, it's Tethers Unlimited.
Morning, and I hope everybody's excited about all this as I am. I'm seeing a lot of great questions, and I swear I had nothing to do with that question that was read this morning, which is perfectly leading into what we're doing. I'm a huge fan of science fiction. I'm a huge fan of the past and where things were, but I think a lot of us are stuck in the idea of, geez, how are we going to go interstellar if NASA doesn't have the budget? I don't think NASA is going to be the way we do this. I don't think we have to keep looking towards the government to be the solution to all of the problems, and maybe that's because I read too much Heinlein and I'm a bit of a libertarian, but that doesn't really matter. The point is that I believe, and at TUI, I think we're showing that we can really bootstrap our way towards our goals. We can really expand how humans interact with space and how we expand out into the universe by kind of looking at what it's going to take to do that. And I think the previous talk really showed some of that great stuff. We have to learn how to make things that are done in a completely different way. We have a 3D printer that we're putting up on the space station, hopefully within the next month, that might sit there for a while because there's no robotics on the space station to manage the experiment if the astronauts have to come back down because of the little issue that happened recently. And that's, you'll see our solution to that in here. You'll see that we have an ability to make big structures in space. And we've been told point blank, well, we're really not going to let you test those on the outside of the space station because there's no way of ensuring that that hardware you build is any good because you didn't build it on the ground and test it. And we're like, well, we're going to build it in space. Well, right, so you can't test it before you build it. It's a different way of looking at things. And so his discussion of, well, we're going to look at it as we build it and prove that it's good and adjust as we're manufacturing things. It's a different way of looking at things. And the old NASA mindset of safety is very important because there's people involved. And the approach is, I mean, we can say, oh, they're holding us back. They're really important that they've evolved to what they are. But having these new approaches and this whole conference, this is what we've been talking about, is new ways of solving these problems, new propulsion systems, the laser system for pushing things interstellar that we saw yesterday. Some of the discussion I heard afterwards was, well, we couldn't really build kilometer scale objects. Well, we couldn't in the past, but we can now. I truly believe that if someone gave me a reasonable budget, I could build a kilometer scale structure in space within the next 10 years. I just have to find how to get there, and that's what this talk is going to be about, is the approach we're taking to actually get to some of the crazy ideas that we're all having here and we're all discussing. And it's not a coincidence that this is happening at Tethers Unlimited, a company founded by Dr. Hoyt, but to me, the reason I was there was Dr. Forward. Bob Forward was an amazing science fiction author. He was also an amazing visionary with everything advanced space propulsion. He talked about a lot of what I've seen here 25, 30 years ago. And so we're pushing things, but many years into the company, we're starting to realize that we have to kind of bring things back down to reality and find a path forward that is tractable. So it's, again, bootstrapping how we're going to do that. And you can see in our 25 years, we've grown from, I was there when there was 3 of us, and now we're about 75, and that has been a hard growth, let me tell you. That's a tough path for a company to go through. And we're spread out. If you look at our portfolio, it looks like what would come out of a research lab, and it looks a little chaotic, but you'll see hopefully a pattern to what we're doing and why we're doing it. We aggressively go after the pieces that we're missing to go after our big ideas. We've got our space systems, which is about 30% right now, I believe, of our revenue, which is we sell hardware. We sell a water-based propulsion system that could use the results of what Joel was talking about yesterday. And this is a thruster that we've sold 5 or 6 of already, and we constantly have new interest in, that you put water in and it gives you propulsion, and it's not steam. We break it down with electrolysis into hydrogen and oxygen, and it's a straight up rocket engine at that point. And we get really good ISP, and it's a real product. We've got very, very high performance radios and deorbit systems and gimbals and a wide variety. These are the things that pay for our IR&D that we can't find through some of our sponsors. Some of the, a lot of what you'll see here started with NIAC and other SBIR type funds, some pretty crazy DARPA funds that were allowing us to look at concepts that really push things past what the state of the art really thought was possible. The middle section here is a big chunk of who we are today. We call it Firmamentum. It's our in-space manufacturing, it's our robotics, it's our additive manufacturing, it's our in-space assembly, it's all those things that are the culmination of these little pieces that we've got on the slide here, which I'll get into a little bit more, some of them. And we still do have a few tether things. A lot of it's in our defense systems. We've got some new space tether stuff that's coming back, because it always comes back, but that's not our focus, even though that's still our name. So what does that bootstrapping look like? There's a rather large ecosystem of what in-space off-world economy might look like, and it includes the Deep Space Gateway. It includes what we call our orbital shipyard, which is where we would do our business, where we would build large structures. It includes utilizing the resources that maybe somebody will bring back from an asteroid. You hear a lot of people talk about, well, we go get an asteroid and we'll bring it back and then we'll use it to do all these things. And so we're looking at, okay, if they really do that, what could we do with all that water? What could we do with those raw materials? We've got our microgravity materials and manufacturing, which is really a wide variety of things. We've got multiple space station payloads that we're putting up to look at recycling of materials, manufacturing on the station, testing those pieces that have been built, refinishing pieces that other people have built, really the whole gamut of how would you build things in space, because it's kind of important for a sustainable space future. We try to address the needs of the space tourism, because that's probably what's going to push things forward. At some point you have to find a profit center, and that seems to be the one that's most likely to move forward. To me, if you've seen any of my talks in the past, which there haven't been many that made it onto video, but boy, a few of them where I really get off the rails, it's talking about space debris. I don't look at it as, oh, we're going to get rid of it. I look at it as, oh, I want that. There's tons and tons of metal floating around up in space, and if I can take that and do something useful with it, that's way better than just deorbiting it, which is kind of the foundation of our company, was deorbiting space debris, because space debris is a huge problem with continuing manned presence in space. And the solution to me is let's gather that stuff up and reuse it. And at that point, some of the same techniques that we've developed for utilizing asteroid resources, it's the same thing. I'll take that material, whether that's lunar material, whether that's asteroid material, or another spacecraft, we'll recycle that. And we right now have a paid contract where we're looking at recycling an ESPA ring, a real simple starting point. The ESPA ring goes up, the payloads go away, and now we're going to eat that thing up, grind up the particles, melt them, make some source material, and make some antenna pieces, and then reuse that. And that's, I think there's a slide in here about that, to really address how do we recycle these things, how do we clean up by making it not a problem but a resource. And that's going to allow us to get around the fact that we can't afford billions and billions of dollars of launches to see the fruition of our dreams as to what space could be. Propellant depots is an interesting one. We've toyed with, well, we've got a water propulsion system, and we've got these capabilities that are coming online to build these big depots. Maybe we'll be that gas station. Really what we've realized is somebody else, maybe they'll go get the water, or they'll launch the water, or somehow we'll make that depot for them. But without having users of that, they have no reason to have a depot. And so we have to look at, all right, well, maybe we'll provide the servicing capabilities and the space tug that can move. You get launched into one orbit, it's not quite what you want, we'll move you over here. But if we do that all using water from that propellant depot, and we use water just because we have a water-based propulsion system, but we could use whatever if that existed, it's kind of closing the loop of become the customer as well as develop the market, as well as be the provider, trying to look at how to solve those problems. We can't do it all ourselves, obviously, but luckily there's a lot of people looking at that problem. Joel's talking about going and grabbing the water from the asteroids. We've got other people talking about building these propellant depots, and if we can all work together towards that common vision, I guess, and it's a vision. It's not a plan. We're not going to be worried if we don't stick to it. We're going to gradually build up the pieces and then opportunistically fold in what other people are doing to come up with this whole off-world economy. I'll get into some of the details here, but I'm going to go through this kind of fast to try and get us on schedule. On the left here, you see our sourcing of materials using some of the different technologies, and then some of the components, and then some of the on-orbit assembly, and some of the services. This is all stuff that we're working on, with the exception of the lower left, harvesting raw materials in space. We're still looking at how best to approach that problem. But you can see on the right, there's some pretty audacious, large-scale things there. I mean, I guess it's hard to tell they're large scale, but those are really big structures. And that's kind of where we see the future of everything we're working on. And is it going to play? If you look on the left side, you can see a video of our trussellator building I think that's about a 10-meter boom. It started on rolls of raw material, and it is building a truss structure that just is going straight up into the air. You'll see, if you watch the video, it's kind of sped up. You'll see somebody having to add a support structure up there because the wind kicked in after a while, of course. But this approach with our constructible structures is kind of unique, and it's kind of problematic with some ways of thinking about how to build things. But we essentially send up raw materials, and they're usually, for this particular stuff, it's thermoplastics, carbon fiber reinforced thermoplastics on rolls. And we form that into these truss structures. So it's essentially, we build 2x4s, but we build 2x4s where something the size of this podium could make something the size of the space station, because it's very, very dense. And if you start looking at building really large structures, you'll fairly quickly realize that you're fairing limited. It isn't a launch mass problem, it's a volume problem. If you were to send up a bunch of tubes to make a large truss, and then a robot assembles those tubes, they don't stack that well. It's mostly empty space, and so you can only build so big a structure before your fairing is just completely full, and you've used 10% of its available mass. So what we've looked at is how can we make basically those 2x4s in space to build whatever you want to build, and that's how we kind of evolved into our trussellator program, which builds these very large structures, and the scale of these is really unlimited because we can refill the source material. So if you have this amazing launch capacity that's coming online with all these small launch vehicles, if each one provided, well, if every month we got a new container full of material, we could just keep building on whatever structures or whatever antenna farm or whatever it is we're trying to build. You'll see a few of the near-term things. One of the tipping points that we've had recently was the Dragonfly program, where we're looking at adding antennas to a geostationary satellite, which essentially doubles or triples the revenue of these vehicles. They are limited by how many of these antennas they can fit on deployable booms in the fairing. It's just a geometry, it's just a packaging issue. And so by having these deployable booms that go out and a robot that can stick an antenna on the end, we found that we're able to greatly expand the revenue stream of these geostationary birds. And we're waiting to hear how that tipping point moves forward into the next phase, which is the flight demonstration. But this is a step using what we've developed for building very large space structures. This team has said, well, we want to use this right now for this smaller thing, and it could very well be that stepping stone that gets us to be able to build the larger things. The foundational space science is really MakerSat. That's formation flying, essentially, but with a big boom connecting them, and that's a single spacecraft that would build a 50 to 100 meter boom between the two end pieces so that you can do some things. And we mostly focus on the science because the other applications looking back down at Earth usually get funded by different people that maybe don't want to talk about what they're doing with it, but it's very interesting stuff. And we find that just the radar elements alone, looking back down at the Earth, really are amazing because, again, you can get that SAR on a very small spacecraft that doesn't cost very much and really open up the capabilities of small spacecraft. So here's MakerSat. You can see it's a fairly reasonable sized spacecraft that we're hoping will launch hopefully in the next 5 years or so. We'll see how that comes along. 50 to 100 meters. Okay, good. Constructible antenna. This is the one I was talking about with it's called Orbweaver. It's eating up an ESPA ring, taking the raw materials, the aluminum from the ESPA ring, and making antenna dishes, and then placing those out to essentially recycle that ESPA ring. Mantis seems like an odd one because why are we building robotics? This is a servicing robot to go on the space station that fits in the lockers that most of the payloads are in. And this is something we developed over many years. The NRL was the first customer, and we've had quite a few since then. And we wish it was already there because, like I said earlier, we have a payload going up on the station that might just sit there for months if the astronauts don't get to it. And this would allow us to do that. And we've also got this is integral to our Fab Lab experiment, which is going up hopefully within the next few years, which is a completely integrated fabrication facility, which uses robotics instead of an astronaut to service it. Well, why are we doing that? That's all neat. That's a great revenue stream, and we're building some great hardware, and we're really having a lot of fun with that. But our goal is to have that supporting our other elements. We got into robotics but because we looked at where do we want to go, and we looked at what's left. What are the pieces that are missing? And we realized that, well, we really need to expand our robotics because in-space manufacturing requires this in-space assembly to do things with the things you manufactured. And so to build these large structures, we needed to build robotics. And that's kind of really the point of what we're trying to say here is that if you want to build this very large laser platform to push light sails out, and you're a little intimidated by how you're going to build that doesn't exist. Well, it can exist, and you have to just look at what are the pieces that are missing. We've got the capabilities for building that large structure. We've got the robotics to assemble it, the pieces that we build. We can start to build these larger things because we've systematically looked at what are the pieces that are missing to do that. And I think when I've heard multiple people here during the breaks talk about, well, these are great ideas, but how can we make them happen? And I think that is the key, is don't say, well, how can we get NASA to redirect, but how can we make a vision and a story of how we're going to get there and what are the pieces that are missing, and then break that up and rely on one person to do one part, another group to do another to do another. And if you have all those pieces covered, and then maybe there's one left, go to NASA and say, hey, we're missing this. Could you focus on this? Could you give us some money to focus on this? And most of what I've shown you here was funded by exactly doing that, by identifying the big picture. I'll look at that. This is our strategic plan and schedule, which is obviously way too small to read. It's not intended to be read. It's showing that we've got our final product here, and what are the steps to get here. And the way we get all these pieces is by looking at the end product, aggregating that back down to what are the pieces that are required, and then focusing on getting those. And as a small company, that's a lot to take on, but we luckily have a lot of partners for the pieces that we don't actually have ourselves. There we go.